In this video, we are going to be looking at addition and subtraction of exponential expressions, okay? So when we add and subtract exponential expressions, we are going to use a different method completely total from when we multiply and divide. You'll see it just now. Just tune in and watch. I hope this video becomes beneficial. Okay, let's start. So ladies and gents, always if you see a minus, so I'm seeing a minus there, I know that I have to split my terms there. So we're going to split our terms, but before we do that, we need to make sure that everything is simplified, okay? And you are only interested in the parts with to the power of x, ne? So you're interested in this part, that part, that part, and that part. Why? Because they're the ones that have an x as an exponent, right? You always make sure that those parts, the values of the bases are in prime numbers. Ne? So you must know this method on the calculator. Let me take the calculator out. So you see 4 is not a prime number. I'll show you how to convert them to prime numbers. So you type 4, then you say equals to, then you say shift fact. So which means 4 can turn into 2 to the power of 2. So we're going to do that. So 4 changes into 2 to the power of 2. And then you have x outside. Dot 2 is already a prime number, so that one is not an issue. So it's going to be x plus 2, right? And then, okay, let's zoom in more, guys. Let's zoom in more. Sharp. And then we're going to have minus. We're going to have that minus here. Let's see what does 8 turn into, right? So we know that it turns to 2 to the power 3, but I'm just teaching you the method of getting them on a calculator. So you type your 8, you go to equals to, you say shift effect, which becomes 2 to the power 3, then x, right? Then at the bottom, you have 2 squared, you have the 3 to the power 0, you have that 2 to the power 3x. All right, and then you are going to simplify this. Remember, this exponent will multiply with that. So you're going to have base 2 to the power 2x multiplied by 2 to the power x plus 2, subtract. Remember, this will multiply that. So it's going to be 2 to the power 3x all over. 2 to the power 2 multiplied by 1, because anything to the power 0 becomes 1, then multiply by 2 to the power 3x, right? Perfect. And then, ladies and gents, if you check here, this part here, right? I'm basically multiplying the same basis. I can add the exponents. So I'm going to write 1, 2, and then it's going to be 2x plus x, which gives you 3x. This guy does not have a mate, so we're going to write him like that. Ne? Then minus 2 to the power of 3x all over 2 to the power 2 dot 2 to the power 3x. And then from there, we're going to do this. You can now split. Ne? You can now split. So let's split now. This guy here is going to split into 2 to the power 3x dot 2 to the power 2. This guy here is already having one term, so nothing to split. So we just have that all over 2 to the power 2 dot 2 to the power 3x. And then from there, we are going to highlight the parts with x to the power, with the exponential power of x. Ne? So you are just interested in these parts. Sharp. So let's see now. So what do? Is this. You can see that this guy and that guy are common on top. So they're going to come out as a common factor. You have to factorize them. And then you do this. So what you do basically when you factorize, right? It's like you are replacing this guy with 1 and that guy with 1. But obviously, you will use a pencil and erase it. It's just for making things look easy for you. So you're going to write 1.2 to the power 2 minus 1. You see, I wrote everything 1 times 2 to the power 2 minus 1. And then at the bottom, there's no need to factorize because I'm multiplying, right? You cannot factorize terms that are multiplying. You only factorize terms that are adding and subtracting. So at the bottom, I'm going to leave it that way. So we have 2 to the power of 2.2 to the power of 3x, right? Sharp. And then we can all see that this guy, and that guy will cancel, right? So you are basically, but I don't advise you to show the canceling because the marker might find it difficult to see what you had there. I advise you to cancel it in your brain. So you know that this part and that part are gone now because they canceled each other. Let's write what is remaining. So what remains in this case is going to be 1 times 2 squared, which is 4, minus 1 all over 2 squared. Because this guy is gone, is cancelled with that 1. And we can all see that 1 times 4, it's 4, minus 1 will give you 3 over 4, right? And that is your final answer for number 4, is 3 over 4. And there's a way to actually see if you are right. I'll show you with number 4 only, and then you'll always going to verify for yourself for the rest. So what do you do? It's like you treat each x as 1. You replace this with 1, you replace that with 1, you replace that with 1, you replace that with 1. So let's see what we're going to get. So I'm going to just type everything on the calculator. So it's going to be 4 to the power of 1 multiplied by 2 to the power of, you can see that it's going to be 1 plus 2, which is 2 to the power of 3, minus 8 to the power of 1, all over 2 squared, multiplied by 3 to the power of 0, right? Then you can see it's going to be 3 times 1, which is 3, so it's 2 to the power 3. So multiplied by 2 to the power of 3. The answer must be 3 over 4. Then you know that you did it properly. So I showed you how to test your solutions for exponential expressions. This testing method works for all type of exponential expressions. You can use it to test if your solution is correct. Thank you. Let's now go to number 5. Okay, on number 5, remember I said immediately you see a minus, you know that you have to split. But before you split, remember you're interested in the basis with variable exponents. So you're interested in those 3. This one doesn't matter, doesn't have a variable exponent. This one doesn't really matter, it doesn't have a variable exponent. So now, this is what you're going to do. You check if everything is prime. In this case, you can see that this is a prime number, this is a prime number, and that is a prime number. So from there, you can basically just start working, right? So you can start splitting them if everything is in prime. So we're going to say equals to 3 to the power y dot 3 to the power 4 minus 6 dot 3 to the power y dot 3 to the power 1 all over 3 to the power y dot 3 squared dot 2. Right. Then remember from here we have to highlight the ones with letter R. Sorry about that. We have to highlight the ones with letters. Let me get a nicer highlighter. I prefer this color, which is lighter, right? So we're going to highlight that. We're going to highlight that. We're going to highlight that. Sharp. Then now you can see that on the top, you have two terms and this is common. This guy and that guy are common. So we take them out as common factor. So 3 to the power y. Whatever it was, we put 1. So it's going to be 1.3 to the power 4 minus 6.1.3 to the power 1, which we don't write, right? All over, but you can put it if you want to. So I'll just put it for this case. Then you have 3 to the power y dot 3 squared dot 2. The reason why I cannot really factorize at the bottom is I have one term, and that term is attached by multiplications. Remember, you can only factorize more than one term. If you have one term, you cannot do really anything. So you can see that this guy will cancel with that guy. This guy will cancel with that guy. So you're going to have 1 times 3 to the power 4, which is 81. So here you have 81 minus 6 times 1 times 3 will give you 18. All over 9, because 3 squared is 9 times 2, which is 18, right? And then we get 18, 81 minus 18 gives you 63 over 18, which gives you, let's see, 63 over 18 gives you 7 over 2. Okay, ladies and gents, I'm just going to test this with you for the last time, and then going forward, you must know how to test. So you replace all the y's with 1, sharp. So you do this. You're like, okay, I have this, then I have 3. You can see it's going to be to the power of 5, because 1 plus 4. So 3 to the power of 5. And then you have minus 6 times 3 squared because of 1 plus 1. All over 3 to the power of 3. I'm sure we can see that now, times 2, because 1 plus 2 is 3. So it's going to be 3 to the power 3. Let's see. See, you get 7 over 2. So ladies and gents, now that you get the hang of this, I advise you to pause the video and attempt the question and check the solution, and keep on doing that. That is what is advised in this YouTube channel. Ne? So we're going to go to number 6. Let's go to number 6. You check your bases that have exponent, that is a variable there and there. You verify if everything is a prime number. And in this case, you can see that everything is a prime number, which means we can now start by splitting. So you have 2x dot 2, 1 plus 2x dot 2 minus 3 all over 2 squared minus 2, dot 2 to the power of negative 2 plus 2 to the power of x, because this one is by itself. You see? Sharp. I'm sure from here you know that we need to highlight this part, that part, this part, and that part, right? Sharp. And then I said you know that you are going to take out a common factor here because you have a plus and this is common. So let's take it out. So it's going to be 2 to the power x. And then you have, let's see, you have, okay, you're going to have 1 multiplied by 2, because this, remember I said you replace by 1, you replace by 1, you replace by 1, by 1, by 1, by 1, right? But obviously you use a pencil and then you erase it at the end, right? Your work must be neat. So then it's going to be plus 1 times 2 to the power negative 3 all over. You take out a common factor again there. So it's 2 to the power x. Here I'm left with 1 dot 2 to the negative 2 plus 1. Right? And then you can see that this guy will cancel with that guy. You are allowed to use a calculator now. Ne? You just need to show your steps. So here we can say, okay, 1 times 2 plus 1 times 2 to the power of negative 3. That is the top. So the top gives us 17 over 8. Then we are dividing it by the bottom, which is this. Let's see. What will the bottom give us? So you have 1 times 2 to the power of negative 2, then plus 1. That yields 5 over 4. Then now let's see what we are going to have, right? So we are going to have this. We have 17 over 8 multiplied by, remember you tip and times, this is going to be 4 over 5, right? Then we can all see that 8 goes twice into itself and once into 4. So now you can see 17 times 1 is just 17 over 5 times 2, it's 10. So you get 17 over 10. If you were to verify with that method of replacing the x's with 1, your answer must be 17 over 10. Okay. Perfect. Let's move to the next one. To the next one. Let's move to the next one. So let's do number 7 now, ladies and gentlemen. On number 7, remember, I'm seeing a minus. So if I see a minus, I know I'm just interested in the basis with a variable exponent. And don't forget to pause the video and attempt this on your own and then resume. Okay, perfect. So you have 3 to the power 2r minus 4 dot 2 to the power r dot 2 minus 2. Do you see it? And then you have 2 to the power r minus 2 r dot 2 minus 1. Right, and then after splitting, I'm sure now you get the steps. You need to highlight the ones with letters as the exponents. Ne? The rest you're not really interested in. Then remember we said we check if we have a common factor. Yes, and top we have a common factor, which is 2 to the power r. I'm sure you can see that this will be 1, that will be 1. So you're going to have 3 times 1 minus 4 times 1 times 2 to the power negative 2. Right. Then the bottom, we can take it out. Remember, you replace this whole thing with 1 and that whole thing with 1, right? So let me use a different color then. So we're going to have this. This will become 1. That will become 1. This will become 1. That will become 1. Because we're taking out as a common factor. So you have 1 minus 1.2 to the power minus 1. And these guys cancel. And then let's check what we have on top. So remember, I said you're allowed to use your calculator. So it's 3 times 1 minus 4 times 1 times 2 to the power negative 2, which gives us 2 on top. Then let's see what we get at the bottom. At the bottom, I have 1 minus 1 times 2 to the power of negative 1. And that gives us half, right? And then what is 2 divided by half? I think the answer must be 4, right? Perfect. If you check with whatever the checking method I showed you, your answer must be 4. If it's not 4, it means I made a mistake somewhere. And if I did, please leave a message on the comment section. Okay. Perfect. Let's do 3. Let's do 8. So on 8, ladies and gents, we have the same scenario, but now you can see that your bases are there, there, and there, right? So we're going to take 3 to the r plus 3 to the r dot 3 squared all over 3 to the r dot 3 to the negative 1 plus 3 to the r. And then you highlight this guy, this guy, this guy, and that guy, right? You always highlight the ones with an exponent that is a letter. The rest you leave them. Sharp. And then we can see that, okay, in this case, we're going to have 3 to the power r as a common factor on top. And remember here we said we replace with 1, then plus 1 times 3 squared. All over 3 to the r, here we're going to have 1 times 3 to the negative 1 plus 1. See? Then you can easily see that this will cancel that. Now let's see. What is 1 plus 1 times 3 squared? So this is 9. So you're going to have 10. Let's check at the bottom. So at the bottom, you're going to have, let's use a calculator to save time. So we're going to have 1 multiplied by 3 to the power negative 1. And we're going to have plus 1. So that it will give you divided by 4 over 3, I think. Yeah, write it properly. Yes, so now we're going to say 10 divided by the answer, which was 4 over 3, which gives you 15 over 2. If you verify using the method I showed you, it must give you 15 over 2. At the bottom, we need to I'm sure we can see that on question 9, ladies and gents, the bases with exponents of x are all prime numbers. So we are sorted here. We just need to split. Gonna be 5 to the power 2 dot 5 to the minus x. Then you have minus 4. Then you have 5 to the power negative x, which is already split. This guy also it's already split, so we're not worried about him. That, right? Then you have plus 2 multiplied by, we need to split that guy. So it's 5 minus x dot 5 to the power of 1. All right. Then now we highlight the ones with exponents of x only. Remember, you're only interested in the ones with exponents of x sharp. Then you're going to start factorizing now where it's factorizable. At the top, you have 2 terms. You have here and there, and it's exactly the same. So you're going to take it out as a common factor. And then you have 5 squared dot 1. Do you see it? Remember I said wherever it was the one that you're taking out, you replace with 1. Then minus 4 dot 1. All over, you do the same at the bottom. There's a common factor of that. You're going to replace that with 1 plus 2 dot 1 because it was there. Then dot 5 to the power 1. I'm sure you see that everywhere where there was a highlighter, you replaced with 1 now. You see it? Sharp. Then this will cancel that. Then we have 5 to the power 2 times 1, which is just 5 to the power 2 minus 4 on top, all over 1 plus 2 times 1 times 5 is 10. And then this gives us, let's see, here we have 25 minus 4, which is 21. And then at the bottom, you must get 11. Right. And that is finito. If you check, you can just use that method of testing. Your solution should be that one. Let's quickly jump to number 10. This is the base with a letter. This is the base with a letter. And that is the base with a letter. And all of them are prime bases. Don't forget, ladies and gents, to pause the video before starting before looking at each solution. Make sure you pause, you start it on your own, and then you look at the solution. That is how you're gonna learn mathematics. You learn it by doing it, not by just watching, right? You try, even if you go wrong, and then you play the video, you'll be able to see where you went wrong, right? That's how you learn. You learn from mistakes. Awesome. So in this case, as I said, all the bases are prime. We can just split. So it's going to be 3 to the power n dot 3 to the power 4 minus 6 dot 3 to the power n dot 3 to the power 1 all over 7 dot 3 to the power n dot 3 squared. All right. And then remember you highlight these guys, right, with letters only. You highlight these guys with letters. And then at the top, because you have two terms, you take them out as a common factor. And then you are basically rewriting everything, but where the highlighter is, you put 1. So it's going to be 1 times 3 to the 4 minus 6.1.3 to the power 1, which is just 3, right? All over 7.3 to the power n dot 3 squared, which gives us this will cancel with that. You see, at the bottom I cannot factorize because it's already in factored form. These are the factors. Basically, it's already factorized, right? So this will cancel with that. Remember, I advise you not to show it, but just know it in your brain. So you have 1 times 3 to the power 4, which is 81. And then this times that gives you how much? It gives you, let's see, it gives you 18. And then at the bottom, we're going to have 7 times 9, which is, let's check quickly what is 7 times 9. 7 times 9 is 63, okay? So we're going to have 63, which is, at the top, it's 63 as well when you do the difference. So 63 over 63, which gives you 1, right? I want us to test, so that I remind you how to test. Remember, I said you replace all the ends with a 1, and then you type on your calculator, right? So what do? You have 3 to the power of, here you're going to have 3 to the power of 5 minus 6 times 3 to the power of 2 all over 7 multiplied by 3 to the power of 3. Let's see what is the answer. The answer is 1. Then you know you're fine. Then go. Right. Awesome. So now let's go to 11. Let's go to 11, ladies and gents. So in 11, I'm still adding, so I need to trace my bases with letters. So those are my bases with letters. I need to split them. So there, and then there. Right, this becomes 2 to the power n multiplied by 2 to the power 5 plus 3.2 to the power n dot 2 to the power negative 2 all over 5 multiplied by 2 to the power n multiplied by 2 to the power 3. And then we highlight, remember, the step after splitting, you highlight the ones with letters only. So there, which gives you, at the top, you can take out a common factor because you have two terms. Then remember, I said the highlighter is replaced with 1, but you're just rewriting everything. Plus 3 to the power, times 1 times 2 to the power of negative 2 all over 5.2 to the n dot 2 to the 3. Right. So now this is what you are going to do, ladies and gentlemen. You can see that this guy will cancel with that guy. So you are completely allowed to use a calculator after the canceling step. So I'm going to say, but just do the numerator first, then the denominator, and then simplify from there. So I'm going to say 1 times 2 to the power of 5 plus 3 times 1 times, sorry. So it's 1, right? Multiplied by 2 to the power of 5. And then I need to come here to say plus 3 multiplied by 1 multiplied by 2 to the power negative 2. Right, let's see what does that gives us. That gives us 1, 3, 1 over 4. Right. And then we're going to divide that by the bottom, right? Let's see. So we can see that, okay, 5 times 2 to the power of 3. Where's my cube? Okay, I know, let me just do this and press the sharp. So which is divided by 40, right? And then remember these guys are going this one and that one, so you don't have to worry about that. Then this simplifies to, you can just check there. You can say 131 over 4 divided by 40, which is 131 over 160. You see? And then, ladies and gents, that is the answer for number 11. Remember, these questions, they will always say simplify without using a calculator. What they mean is you have to show the working out. They don't necessarily mean that you cannot press your calculator at all. You are still allowed to use your calculator, but show all the steps, as many steps as you can. Okay, then you should be fine. Let's now look at number 12. I'm going to look at number 12 now. Okay, let's look at number 12. Number 12. Okay. What's happening here? My system is jamming, guys, today, but it's fine. We're gonna force, we're gonna work hard, gonna push, right? Nothing must stop us. Okay. So now we're going to do 12. Right. On 12, this is your base, that's your base, that's your base, that's your base. You can see I skip 4 because it does not have a letter. You're only interested in the bases that have letters. So you're going to split them. So 3, 2 to the m, it's already split, minus 4 dot 2 to the m dot 2 to the negative 1 all over 2 to the m minus 2 to the m dot 2 to the negative 1. Then let's highlight quickly. Highlight, 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 highlight. Right. Then from there, you take out a common factor of 2 to the power m, right? And then you're going to be left with, guys, let me change the pen. This is Jimmy now. Okay, so now we can see that, okay, we left with 3, right? Dot 1 minus 4 dot 1 dot 2 to the negative 1 all over. You can take out the common factor again here. So 2 to the m. And then you're going to have 1 minus 1 dot 2 to the power minus 1. All right. And then this guy will cancel with that guy. Right. Let's see what does the top give us on a calculator. It's going to be 3 times 1 minus 4 times 1 times 2 to the power negative 1, which gives us 1. Do you see? So the top gives us exactly 1. Then let's see what does the bottom give us. The bottom gives us 1 minus 1 times 2 to the power negative 1, which becomes half. And we all know that 1 divided by half is 2. Right. And verify that 1 divided by answer is 2. And then that is the solution for 12. Right. Perfect. Now let's do 13. On 13, you trace your bases. They are all prime, so you know you are sorted. So you need to split them. So it's going to be 3 to the power x dot 3 to the power 1 minus 3 to the power x, which is already separated, all over 3 to the power x dot 3 to the power 2. Let's see, minus 2 to the power 3x. It's separated, 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 and separated. Now you can take your highlighter and highlight. So highlight that, highlight that, highlight that, highlight that, right? Perfect. So now in this case, we are going to do this. We are going to take out our common factor, right? Then you can see that at the top is 3 to the x as your common factor. And then you're going to have 1 times 3 minus 1. Do you see it? Then at the bottom, your common factor is 3 to the power x again. And then you're going to have 1 times 2 squared minus 2 times 1. You can see that everywhere where there was a highlighter, you replaced with 1. This guy cancels that guy. And at the top, you're going to have 3 times 1 minus 1, which gives you 2. At the bottom, you're going to have 1 times 4 minus that, which gives you 2 as well, right? And then let's see, guys, we're going to have, am I right? So this minus that gives you that. Yeah, that's fine. Then the answer is 1, right? Let's verify if we find. Let's verify if we find. Remember, you're gonna have 1, 1, 1, and 1, right? So let's see, what does that give us? So we're gonna have 3 squared minus 3 to the power 1 all over 3 to the power of 3. And then it's gonna be minus 2 and then times 3 to the power of 1, which gives you, oh, it gives us 2 over 7. You see, if it gives us 2 over 7, it means there's somewhere where I made a mistake and I need to go back and check where did I do the mistake, right? Sharp. Let's see. Okay, I know where I made a mistake. You see, it's always here. I'm showing you the importance of checking your sum. So my mistake is here, ladies and gents. This will be 3 to the power 2. You see? So I just did that intentionally so that at the end, I'll show you why it is important to check. Ne? That's why I decided to check that one, because I knew I had made a mistake then. Then I wanted to show you that it's always important to check. So when I split here, I made that a 2. So which means here I have a 3. Which means I'm going to have 9 minus 2, which is 7. Do you see? So you have now 2 over 7. I'm sure that makes sense, ladies and gents. Right. So ladies and gents, if you got up to so far with the video, I would like to congratulate you. You're really a mathematical person. Eh? You're really going to do well in maths. The last few questions are star questions. Ne? Star questions. And you can continue to watch, ladies and gents. You can continue to watch if you got this far. Well done. So now we're going to do a little bit challenging questions on exponential expressions. Ne? They are not that super challenging, just a little bit, ladies and gents. Don't worry. So let's look at 14, right? On 14, I'm like, okay, I have this, right? I have wait, I have this guy and that guy, which is the guys that we're interested in, right? Right. So I'm going to like, okay, can I split this? No. Can I split that? No. Right. They're already split, right? And then the other thing that when I check is I don't have a common factor here. So I cannot take out a common factor, right? So I'm going to now try to compare the exponents. Ne? Check. This one is x, that one is 2x, ne? Which means you can do this then. You can say 2 to the power x dot 2 to the power x. You see it? Then minus. Oh, I see that this is a perfect square actually. So it's going to be 1 times 1, because 1 times 1 will still give you 1. This and that will give you that. Then at the bottom, there's nothing you can do. You leave it like that. So guys, you need to know that exponents can also be factorized like normal algebraic expressions. In this case, we have difference of two squares on top. Ne? Remember, when you factorize difference of two squares, this guy will come into this bracket. This guy will come into this bracket. This guy will come into this bracket. That guy will come into that bracket. And then the signs are always plus and a minus, right? Then here you have 2 to the power x plus 1. You can see that this guy will cancel with that guy. So you are basically left with 2 to the power x minus 1. Then that is finito, ladies and gents. You see, here the strategy was to see that this exponent is 2 times that one, which means you must have difference of 2 squares on the top, because there's a minus and 1 is also a perfect square, right? Let's do 15. So you have this, you have that, you have that, right? So obviously 3 is a prime base, 9 is not a prime base, 72 is not a prime base. We need to change them to prime bases, right? Remember 3, we know that it's 9 squared. I mean 9, we know that can be represented as 3 squared, so that one it's easy. All over. Let's check what 72 can be presented as. So we're going to say, okay, we have 72 equals to shift fact. So it can be represented as 2 to the power 3 dot 3 to the power 3, if I'm not wrong. Let's check. Or 3 to the power 2. Okay, sharp. And then now we can simplify. You're going to have 3 to the power 2n minus 3. Remember, this 2 will multiply the n and the negative 1. So 2 times n, it's n. 2 times negative 1 will be minus 2. All over. This must multiply with that as well. So you're going to have 2 multiplied by 3n dot 3 to the power 2n. Right. And then you can split now. So it's 3 to the power 2n minus 3 to the power 2n dot 3 minus 2. All over 2 to the power 3n dot 3 to the power 2n. Then remember, after splitting, you can, you can highlight. So let me take my highlighter. I'm going to highlight this part, and that part, right? So we take out a common factor on top is 3 to the power 2n, right? What will that give us? That should give us, let's see. So we have 1. Take this up. We need to go up a little bit. So you have 1 minus 3 to the, 1 minus 1 dot 3 to the negative 2 all over 2 to the power 3n dot 3 to the power 2n, right? And then you can see that this guy and that guy are cancelling. So at the top, what am I going to be left with? Let's see. You have 1 minus 3 to the power of negative 2. That gives you 8 over 9, right? That gives you 8 over 9. So you basically have 8 over 9, and then times 2 to the power 3, and it remains at the bottom. Do you see it? And that is your final answer, ladies and gentlemen. Okay, perfect. Now let's go look at the last 2 questions, right? So I have 16 and 17, which are also a little bit challenge questions. So this one, we agree, ladies and gents, is gonna, I'm sure now you're advanced, ne? You can see what is happening. So this will be 2 to the power 2n, because 4 changes to 2 squared, minus 2 to the power n dot 2 squared plus 4. How many terms do I have? I have 3 terms. I know it's going to be a trinomial. Ne? Then it's going to be 2n minus 2. Right. So the top I can factor. Okay, let's simplify it first. Ne? So it's going to be, remember 2n, I can represent it as 2 to the n dot 2 to the n. You agree? This part. Then I can say minus 4 dot 2 to the n, because this becomes 4. So I just wrote it that way. Then it's going to be plus 4, right? All over 2n minus 2, right? Then now we can, to make things easy, ne, just do this actually. Say let, right, 2 to the n equals to k. When you have a trinomial, use the k method. Ne? So you're going to have k times a, k times k, I mean, which is k squared minus 4k plus 4 will give you k minus 2, right? And then from there, we can go up a little bit. Yeah, so we're going to have 2 brackets. K squared will be k and k, right? And then because we need the negative and we have a plus here, all the signs must be negative, so that when you multiply, you'll get a plus, minus 2, minus 2. Guys, if you don't know how to factorize now, you need to go to grade 10 revision videos and check how to factorize, right? Sharp. And then this will cancel with one of them, but remember I said you don't show it. So you're basically just left with what? With k minus 2 on top, which is basically 2 to the n minus 2. I'm sure we do see it, ladies and gents. And then we now have the last one. Let's see the last one. The last one is a little bit challenging, right? Let's see though. Okay. Remember, just know that you are factorizing here. Ne? Okay. So to make things simple for me, I'm going to let k to be equals to 2 to the, you always choose the smallest, 2 to the power x. So do you agree that here I'm going to have 2 to the power x cubed? This is still 3x, then plus 1. Remember I said the last 3 questions are a little bit advanced. So if you don't get them, it's okay. Keep on practicing and working hard. Ne? But if you are getting the first 14 questions to 13 questions correct, ne? I'm happy for you. It's like you are getting more than 70% of this thing, more than 80% of this section. So you are good. Just go practice more with past papers and then you should be fine. Okay. So I'm going to replace this with k now. So I'm going to have k cubed plus 1 all over k plus 1. And then at the top, I can see I have sum of 2 cubes, which I'll open a small bracket and a big one, right? Remember, the sign here will be the same as the sign in the first bracket, and then here it switches. So if this was a minus, that will be a plus. But now because it's a plus, this one is a minus, and then the last one is always a plus. Ne? So here you have k cubed. Remember, k cubed changes to k, then this bracket will be k squared. 1 will be 1 and 1, right? Then the middle is k times 1, which is k, all over k plus 1. Then you can see that this guy will cancel with that guy. Then you have k squared minus k plus 1, right? What is k squared, ladies and gents? K squared will be basically this, right? It will be let's put what our k is. Our k is 2 to the power x. Then you have a 2 there, minus 2 to the power x plus 1, right? Which gives you 2 to the power 2x minus 2 to the power x plus 1. And that's your final answer in this case. And that's it about this video on exponential expressions, ladies and gents. Keep on looking for more fire content at Maths Fanatics 24/7, and don't forget to share with family and friends. And if you haven't hit the subscription button, please hit the subscribe button and turn on the notification bell so that when the fire content is being loaded, you are with it. Thank you very much for your time and focus. Aluta kontinua. Tango.